This lesson is part of a series of training videos where we will look at a specific product in a specific installation, comparing our installation instructions and good practice with actual conditions on a job site. The primary goal is to help you become more familiar with our products, enabling you to tell if they have been installed correctly and if they're doing what they're supposed to be doing. Along the way, we'll also discuss what's important for when we need to determine if something is close enough, what's dangerous for when we need to bring something to the contractor's immediate attention, and why our products are used the way they're used. These videos will assume you're already somewhat familiar with the products being discussed. If you haven't already done so, please take some time to watch our other product training videos that go into detail on our various products, features, and components. Vibro-Acoustics creates noise control solutions for the HVAC industry, addressing both airborne and structure-borne transmission paths. Our vibration isolation products help mitigate equipment vibrations that could cause noise problems in buildings. In this lesson, we will look at concrete inertia bases on Type FS floor spring isolators supporting hydronic pumps. In late 2016, Vibro-Acoustics secured a vibration isolation order for a project in downtown Toronto called Daniels Waterfront South, a mixed-use condo and office building. The mechanical penthouse of the East Tower includes various pieces of equipment, including 3 sets of pumps on inertia bases: the heating hot water pumps, the condenser water pumps, and the cooling water pumps. Here's a picture of the heating water pumps as installed. As required by the project documents, the pumps are supported by concrete inertia bases on open floor springs. This project was exempt from seismic requirements, so no restraints were included. We'll take a closer look at the installation after we look at our submittal and discuss what we should be looking for during the site visit. Here is a summary page from our submittal showing the various pumps and the inertia bases and springs selected for each. These 3 lines show the 3 groups of pumps located in the mechanical penthouse. We'll take a look at each of these during our site visit, but first we'll look at products used for the heating water pumps, where we supplied concrete inertia bases, type CIB, that were 50 inches by 24 inches by 6 inches, as well as FS2A 500 isolators. Every concrete inertia base is made to order. They can be made any size to match the specifications and the supported equipment. Our submittals document their sizes and important dimensions for installation. These are all things we can easily check on a job site. Here we see that the base for each heating water pump is 50 inches long, 24 inches wide, and 6 inches deep. Inertia bases must have an air gap beneath them that is large enough to minimize the air piston effect and to allow easy inspection and removal of any debris that may short-circuit the vibration isolation. This base is designed to have a 2-inch air gap underneath. You can add the operating clearance to the base thickness and compare the result with the operating height for the isolator support point and determine where the support brackets will be. This graphic is generic and doesn't show the actual bracket locations. In this case, since 6 inches plus 2 inches is 8 inches, and the operating height of the isolator is 8 inches, then the support brackets will be mounted on top of the frame instead of on the side as shown here. Inertia bases for most pumps should be sized to support the first elbows on both the inlet and outlet connections. We'll see that in the site walkthrough. The operating weight used to select the isolators includes the weight of the steel base plus the weight of the concrete that the contractor adds, plus the pump weight, plus a conservative 10 feet of inlet and discharge water-filled piping. Highlighted here is the operating weight of the pump alone, and then the total weight of everything listed in Note 4 below. This number, along with the center of gravity location, is used to select the isolator capacities. For the heating water pumps, since there is equal weight on both the discharge and suction ends, take the total weight, 1,743 pounds, divide by 4 isolators, and round up to the next isolator capacity, which is 500 pounds. The 4 FS2A 500 isolators are listed here, and labeled L1 to L4 in the sketch. We'll talk more about the FS isolators next. We've been reviewing the concrete inertia base submittal drawing, which serves as a datasheet for the base. Now we'll look at the datasheet for the FS isolators. Note that the most recent versions of any of the datasheets or installation instructions are available on our website. They are often subject to changes and improvements, so always refer to the latest for the most up-to-date information. In a previous training video, we went over the various parts of an FS isolator, explaining their uses and functions. This graphic here is meant to help familiarize the contractor with the various components, their names, dimensions, and locations, which are referred to in the notes and instructions. A couple of important dimensions are labeled here: the diameter of the support rod that attaches to the equipment, or inertia-based support bracket in this case, and the hole diameter in the bottom cup for attaching to the floor should they choose to do so. The diameter of the rod is important to know since the hole at the support point must be large enough to allow the rod to pass through. The overall diameter and the operating height, which is measured from the floor to the equipment support washer, are labeled here. The diameter can be checked on the job site to confirm that the isolator is a 2-inch deflection spring, since other deflection springs have different diameters. The operating height can also be checked at the job site pretty easily. As we saw on the inertia base drawing, there will be 4 FS2A 500 isolators supporting the base. As we can see here, the outer spring will be red and the inner spring will be white. We'll look for those spring colors during the walk around. The dimensions for the model used here are shown on this line. The diameter is 5 1/4 inches and the maximum recommended operating height is 7 7/8 inches. You may recall that the inertia-based drawing showed 8 inches instead for the isolator operating height. This slight difference is okay in this case and has been accounted for in the overall inertia-based design. Other notes provide descriptions of the materials used and the function and purpose of different components. This note means that the springs can deflect an additional 50% beyond their rated deflection. In this case, 50% more than 2 inches is 1 inch, so these springs can deflect a total of 3 inches before all the spring coils touch and go solid. It also means they can handle up to an additional 50% more weight than their rated load and still provide isolation. They will not be compressed completely flat unless they've been overloaded with 50% or more additional load. We'll want to make sure there are no fully compressed springs on the job site by making sure there is still space between the spring coils. This note here is repeated from the installation instructions page because it's quite important to make sure the load is centered and that the compression cup stays horizontal to keep the spring from being bent sideways. Finally, in this area, we see the isolator selections and locations, which matches what we saw on the inertia-based drawing. Let's take a quick look at the installation instructions pages for Inertia Bases and FS isolators before we go to the job site. These instructions show how to take the concrete inertia base as shipped from Vibro-Acoustics and prepare it to support equipment and be supported by isolators. We're just going to focus on a few things to look for on the job site. For starters, note that the rebar is located in the bottom of the inertia base form and that the brackets are placed on the base with the toes of the channels pointed up. It is important that the inertia base be installed right side up to work properly. As should be obvious, the inertia base should be filled with concrete. This project didn't use what's referred to as a bolting template, which is used to pre-locate hold-down bolts for equipment, so we won't have to check for those. Once the concrete has cured, the inertia base will be placed on shims to ensure the correct operating height, but as we'll see soon, those shims are only temporary and should not still be in place once the equipment is operating. This is also the step where the isolators are positioned and aligned. Here we see that the equipment is to be correctly positioned on and secured to the inertia base. The pump should be squared away on the base and its center line should be the same as the inertia base center line. It should be anchored to the base with concrete anchors or pre-installed template bolts. The same application requirements apply to any kind of pump. Here we see a base-mounted end suction pump and a vertical inline pump on pump stands. It is best that any elbows also be supported by an inertia base if it has been adequately designed and sized for those. This step shows the isolators being adjusted so that the shims can be removed and the inertia base leveled. We'll check the installation at the job site to make sure the isolators have been adjusted, the shims have been removed, and the base is reasonably level. We'll look at installation instructions for the isolators in a moment. Finally, all of the hold-down nuts should be tightened on all of the isolators. Now taking a look at the installation instructions for the floor springs, we'll zoom in so we can see them better. Some of these instructions were repeated on the inertia-based installation instructions. We'll want to check to make sure the right isolators are in the right locations based on the selections shown in the submittal. For the heating water pumps, they're all the same, so that'll be easy. In many cases with end suction pumps, the isolators on the pump end have a higher capacity than the isolators on the motor end, since they are selected to support the additional weight of the suction and discharge water-filled piping. We'll see that with the other pumps on this job. Note that the pipe and equipment must be at operating weight before final adjustment. This is to ensure the pipe and equipment doesn't move much when the additional weight of water is added to the system. Any movement can add stresses to the pipe which can cause problems. With isolated inertia bases, this means that the shims shouldn't be removed until after the system is filled and the springs adjusted. As stated here, it is important that the isolators are positioned so that the load is in the center and the compression cup stays parallel to the floor, keeping the spring vertical and not bending over, which in extreme cases could lead to failure. Here it says to adjust the isolator, the adjustment nut, which is welded to the threaded rod, should be turned 4 complete turns before going to the next isolator, following the adjustment sequence as shown in the diagram below. This sequence diagram shows 6 isolators, which is more common on a larger inertia base and equipment, but these inertia bases only have 4 isolators, so it's even easier. We can see evidence that these instructions were followed on the job site by looking at the amount of deflection on each isolator. If the installer follows this adjustment method, then the isolators should be very close to their design deflection. However, if the installer tried to adjust one isolator too much before adjusting another, then there will be greater variation and possibly over-compressed springs, a common mistake with spring isolators. And finally, as mentioned already, the hold-down nut should be tightened. So now we're ready to walk around these pumps and look for any installation issues. I'll play the video straight through with commentary, and then we'll go over some key points. My first impression of this installation is that it looks okay. Nothing jumps out as a big problem. I see that only the pump and left elbow are supported on the base. Taking a closer look at the first isolator, it appears straight and secured to the base channel support bracket. Now we'll get down to look under the inertia base and see if the shims have been removed and if there is any other debris that may be short-circuiting the isolation. Notice that the gap is much less than the 2 inches indicated in our submittal, but I don't see anything solid between the base and the floor. This corner isolator seems okay too. Its hold-down nut is secured to the support bracket. Now we'll walk around to look at the other side. The isolators are straight and adjusted and attached to the bases. All the springs have the right colors, red outside and white inside. Moving to the back for a closer look, these isolators also look okay. Minor differences in height like this are not a problem. These springs are nowhere near fully compressed, and if you put your fingers on the coils, you may be able to feel the equipment vibration that is being absorbed by the isolator. Looking again under the first inertia base and then the second one, we see that here too the gap is much less than the 2 inches shown in our submittals, and there's some debris. Instead of using an inline pump stand or stanchion, the discharge elbow is supported with a pipe clamp and threaded rods anchored into the base. Coming around the discharge pipe, we can see the other side of the base and confirm the last 2 isolators installed similarly to the others. So what do you think? Do you see anything we need to have the contractor fix or correct? Or was it close enough? Was there anything dangerous? Did it appear to you to be working? Hold on to your answers for a bit. We're going to go look at the other pumps on this job and then review them all at the same time. Here's the inertia base drawing for the condenser water pumps, and this is the inertia base drawing for the chilled water pumps. Like the heating water pump inertia bases, these bases are also 6 inches deep with a 2-inch air gap and 4 2-inch deflection FS isolators. They differ only in their lengths, weight, and isolator selections. Note again that these drawings are schematic and not drawn to scale. As we'll see shortly, these bases are longer than the bases for the heating water pumps because they are supporting base-mounted end suction pumps and are sized to support both the pump and its suction diffuser elbow. I'll take a moment here to highlight a rule of thumb design attribute. Note that the distance between the isolators here is 59¼ inches. A typical parameter used in inertia-based design is that this distance should not exceed 10 times the base depth, and since this is a 6-inch deep base, we meet that. In some cases with larger equipment, it can be better to increase the depth of the base to minimize the number of isolators required. In cases where weight must be kept to a minimum, the base can be kept thinner and more support points added. While it is possible to make inertia bases as thin as 4 inches, it is most common and recommended industry practice to not go any thinner than 6 inches. It is also industry standard practice for the inertia base to weigh at least what the equipment weighs. These pumps weigh 800 pounds each. These bases weigh 154 pounds each without concrete in them. A quick rule of thumb to use for determining the weight of the concrete is to determine the volume of concrete and multiply it by about 150 pounds per cubic foot. Add the base weight to the concrete, and for this one, you'll get just over 1,000 pounds each, which is more than the 800-pound pump sitting on it. We're going to look at the condenser water pumps first. Per the submittal, there should be FS2A 600s on the motor end and FS2A 800s on the pump end. Referring to the FS2A datasheet, we see that the 600s will have red outer and orange inner springs, and the 800s will have just a single green spring. Here are the condenser water pumps on their inertia bases. I'll go ahead and note that the green springs are on the pump end and the red and orange springs are on the motor end as shown in the submittal. We'll start the walk around on the right and take a closer look. This is the pipe bringing the water back from the cooling tower, located just outside the mechanical penthouse. It is connected to the inlet suction diffusers on these pumps, which are mounted on inertia bases on springs. The first thing I notice is that these bases appear a little too close to the ground. The gap appears to only be about a half an inch at this corner. The isolator doesn't appear to be adjusted or to have much load on it. On a positive note, it is secured to the base. Getting down alongside of the base, we can see light under the base, but also some debris which may be bridging the gap between the base and the floor. This isolator appears to be adjusted and secured to the base okay. The gap here appears to be closer to 2 inches. Let's move around to the other side now. The other motor end isolator also appears to be not adjusted or have much load on it. The pump end isolators also appear lightly loaded, but otherwise okay. I like to use a simple method to determine if something is isolated or floating, where I try to bounce the equipment by pushing on it with my foot. It's a little more difficult to do when holding a camera and trying to take a video, but in this case the pump barely moved, if at all, perhaps due to short-circuiting from debris. I try the opposite corner and have a little more success and get a little bit of movement. In some cases, I've had to stand on the equipment to get it to move. Looking at the second pump, it appears to have more of a gap between the base and the floor, though not quite 2 inches. We can see some debris, though it's hard to tell if it's touching the base. This isolator appears to be adjusted and secured to the base. Notice all the flexible conduit. We'll talk about that a bit later. This corner isolator looks good, though the base is not quite 2 inches off the floor. I should have brought a flashlight to see underneath here. It's a little too dark, so we'll try to move the base and see what happens. I should have put the camera down to do this, but I was able to make the base move a little, so it appears to be floating. Over on the pump end, we can see a bunch of flexible conduits attached to the wall. Looking up, we see the flexible metal hose connections on the discharge pipes and spring hangers on the inlet pipe, which allow the whole system to move. Check out our other videos on these products. So, what do you think of these? Are they close enough, or are there things the contractor needs to fix? Again, hold on to your answers, and let's go look at the third set of pumps, the chilled water pumps. This picture shows the 3 chilled water end suction pumps, all mounted on spring-supported inertia bases and connected to spring hanger-supported piping with flexible metal hose connectors. The first thing I notice is the creative coordination for the floor drain location, and how the housekeeping pads appear to be slightly undersized for the isolators. These flexible metal hose connectors are ineffective for vibration isolation, but can help with reducing pipe stresses. The isolators here appear okay, but the inertia bases are installed closer than 2 inches to the housekeeping pad surface, and there appears to be some debris under them. These isolators are red and green, which makes them FS2A 700s, and these are red and orange, which are FS2A 600s, matching what we saw in the submittal drawing. There might be some debris under here which could explain why that one isolator isn't adjusted very much. These isolators have the correct spring colors, as do these, and they all appear to have been adjusted. I'll tilt the camera up towards the ceiling so you can see that the pipes above are supported with spring hanger isolators, which help to float the entire system and reduce vibration transmission to structure. Back where we started, I'll make one more comment. We see the suction elbows are not supported on the bases, which reduces the amount of weight the springs have to support. So now we come to the fun part. We're going to review these inertia-based installations and see how they compare to the datasheets and installation instructions. We're going to determine if these installations are close enough or if we need to tell the contractor to do something further. But first, let's answer a more important question. Did we see anything dangerous? The quick answer is no. Nothing we saw creates a condition that could lead to imminent failure of equipment support or function. We also didn't see any damage to any of the bases or isolators. So let's move on to our first item. Are the inertia bases filled with concrete with the correct pumps and in the correct orientation? Yes, all 3 have concrete, are used with the right pumps, and are oriented correctly, right side up, and aligned with the equipment. Is the equipment centered and secured correctly? Yes, all pumps are lined up on the center lines of the bases and are secured to their bases. Are the correct isolators in the correct locations? Yes, As we mentioned during the videos, they all have the correct isolators in the correct locations. Are the bases isolators at the correct operating height? No, none of the bases had a full 2-inch clearance under the entire base. There are no shims and it's questionable if any were used. This has led to debris getting caught and hidden under the bases, which may be the primary reason why some of the isolators don't appear to have much load on them. This is the primary problem with this project. I would ask the contractor to at least try to remove the debris under all of the inertia bases to ensure there is no short-circuiting, making spring adjustments as necessary to make sure the inertia bases are supported only by the spring isolators. Once that is done, it may not be necessary to raise the bases to the full 2-inch clearance if there are no noise issues below. However, it would be recommended practice to raise them as close to 2 inches as possible to avoid future problems. Are the springs adjusted straight, not tilted or off center, and not flat? The springs are mostly okay. None of the springs was flat, that is, none of them had all of their coils touching each other, which is definitely good. On some of the bases, however, it's questionable if the proper adjustment procedures were followed since the deflections vary, but that could be partly due to short-circuiting debris. There were a couple of springs that had the load off-center, but none was too far. Since the suction pipes weren't being supported off the base as accounted for in the isolator selection, they weren't deflecting as far as anticipated, but unless there are noise problems, it's not necessary to change the springs to match the lighter load. The primary thing to ensure is that the bases are floating. Are the isolators secured? Yes, to the inertia bases. None of the bottom cups were bolted to the floor, which was not a project requirement and not really necessary in this case since they will see negligible lateral loads. The isolators for the chilled water pump that were slightly overhanging the edge of the housekeeping pad, though not ideal or recommended, have enough support under them to not slip or tilt, so it can be considered close enough. Was there anything else? I wanted to mention that the flexible conduits were a good idea. There definitely should not be any rigid connection with the electrical connections. It would have been better, however, to provide more slack and even a full loop, where space permits, of flexible conduit between connection points, especially to transformers and wall-mounted distribution panels. So that wraps up our discussion of inertia bases and FS isolators as it relates to this site inspection. Our primary feedback to the contractor on this one is to sweep out under the inertia bases and make sure there is no debris that could be causing a vibration isolation short circuit. If they need an installation certification, they will need to raise the bases to have clearances closer to 2 inches. In this lesson, we've looked at the datasheets and installation instructions for concrete inertia bases and FS isolators used with hydronic pumps. We discussed various items to look for during an inspection and assess whether the products were installed in a manner that would enable them to do their jobs. I hope through this lesson you've become more familiar with concrete inertia bases and FS isolators.